In this video, we're going to look at the models of the atom. So based on what you know so far, if you were to circle which model of the atom you think is correct, which one would you pick? A lot of people have seen this model of the atom right here. It's used commonly in cartoons, movies. You'll see it everywhere. So is this one correct? There's a couple other ones here. You may have seen this one here in the physics class before, and this one is commonly used too. So which one's correct? Well, let's talk about the different models. So Dalton was the first one that proposed some ideas about the model of the atom. Dalton proposed that matter is composed of atoms. Atoms of the same element are identical, and atoms can't be divided. So his model of the atom was essentially just a giant sphere. Thompson was the next scientist that came along, and he proposed that atoms contain smaller particles with positive and negative charges. He had the plum pudding model. So we have a positive sphere, and there's a bunch of negative charges inside of his model. Next, we had Rutherford. Rutherford proposed that negative electrons move around the nucleus like planets orbiting around the sun. And you'll see this model commonly used. Okay, this model here is used to explain the very basics of how an atom works. Bohr was the next scientist that came around, and he proposed that electrons travel in energy levels. So the first level, the level closest to the nucleus, holds 2 electrons. The next level holds 8. The third level holds 18. The fourth level holds 32 electrons, and so forth. Finally, we have the quantum model. The quantum model is a mathematical model that calculates where an electron is likely to be found. So all of these little blue dots are possible spots where we might find an electron. Remember, electrons are moving so fast and they're so small, it's hard to tell where they are. So we have this model here to kind of explain where we think they are. And if you notice, we've got a lot of these blue dots kind of concentrated in this ring around the nucleus. So like Bohr's model, we have all these different rings, but they don't follow those nice, neat rings when they orbit around the nucleus. All right, so we're going to go through a couple of examples. We're going to focus on the Bohr model. The Bohr model is the model that we're going to use in chemistry to explain a lot of things. So the first example says, draw a Bohr model of magnesium-24. So let's start with our nucleus. In our nucleus, for magnesium, if you look it up on the periodic table, it is number 12. So it has 12 protons, and it has 12 neutrons. How do I know it has 12 neutrons? Well, it's magnesium-24. So if it has 12 protons, it's got to have 12 neutrons. Let's draw on our first energy level. Okay, we need to find places for 12 electrons. So we have 12 protons, 12 neutrons, and 12 electrons. Okay, so we know that we can fit 2 in the first energy level. So here's 1, 2. Let's draw another energy level. So the second energy level, we can fit in 8. So 2, 4, 6, 1, 2, 3, 4, 5, 6, 7, 8. So right now we have a total of 10. We need 2 more. So we have to draw another energy level here. And we need 2 more electrons. So let's put 1 here and 1 here. Okay? This is a Bohr model of magnesium-24. All right, let's try another one. Draw a Bohr model for a nitrogen ion with the mass of 15 and a charge of -3. Let's start with our nucleus. So if you look up nitrogen on the periodic table, it has 7 protons. Now, if we have a mass of 15, if we subtract our 7 protons from that mass of 15, we end up with 8 neutrons. Now, we need a charge of -3. So let's kind of off to the side here. Let's figure out what we've got. We've got 7 protons. We have 8 neutrons. If we want a charge of -3, that means we need to have 3 more electrons than protons. So 3 more than 7 would be 10 electrons. So let's start to draw in our energy levels. So the first one holds 2. The second one holds 8. All right, and we have found homes for all of those electrons. So we are done with this model here. Now in this model, we're going to interpret the model and pull the information from the model. So the first one says determine the mass number. Well, remember the mass number is equal to the protons plus the neutrons. So we have 11 protons, we have 12 neutrons, so that's going to give us a mass of 23. Okay, to determine the charge, we need to count the electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 electrons. There are 11 protons. There's one more proton than electron, so we have a charge of positive 1. Now let's write the isotopic symbol. If we look up 11 protons on the periodic table, we're going to get sodium, which is Na. The bottom number on our symbol is going to be 11 because that's how many protons are in sodium. The mass number is 23, that's the top number. And then finally, the charge goes in the upper right-hand corner of our symbol. And that is how we would pull the information from a model.